Okay, let's move to the another curve, a slightly complex. It's called the parabolas. First, let's see the definition. What is a parabola? So a parabola is a collection. Collection is a set. Set is a collection. They mean the same thing. A collection of all points P in the plane that are the same distance d from a fixed point f as they are away, they are from a fixed line d. Okay, so that's the definition of parabola. Let's explain what is a parabola. Okay, so we have a line. It can be placed whatever direction or place, and then we have a point f. And then we are looking for a point P, so that, let's see, for one point, you talk about distance between the point and straight line. It means first you draw a perpendicular line through this point P to D, and you get the intersection perpendicular to this right angle. And this is a distance D. And then you can measure the distance between 2 points. This is also distance D. So this P share the same distance, one from the given line, one from the given point. Same distance, always same. So you can possibly estimate this is the same distance, or possibly here. I mean, estimate same distance. You get all such points. You just get collection. This collection is called a parabola. This collection is called a parabola. Okay, so that's a parabola. Parabola. Let's see. We draw the perpendicular line through the point here. Through the point here. This is perpendicular line through this point, and you can easily understand that this parabola is symmetric about this perpendicular line. This perpendicular line is through the focus perpendicular to the given straight line. So the graph is the parabola is symmetric with respect to the line through the fixed point and perpendicular to the fixed line. Okay, so up part, bottom part, they are symmetric. And this is called the symmetric axis. And this point, fixed point, F, is called the focus. Focus, F-O-C-U-S. And D is called the directrix. D is called the directrix. And you see here you have a symmetric. The perpendicular line is called the axis of symmetry. and you will also see that the parabola intersect the axis symmetry at a certain point. This intersection point the intersection of the parabola and the axis of symmetry is called the vertex. It's called the vertex. So there are several geometric conditions: focus, directrix, vertex, and axis of symmetry, and the parabola. Okay, so several names: focus, directrix, axis of symmetry, and vertex. Okay, and also you see that vertex is also on the parabola. So the distance between vertex V and F is equal to the distance from vertex to the directrix. So actually this is the midpoint. Is a midpoint between focus and the directrix. Vertex is a midpoint between the focus and the directrix. Okay? And now we want to write down the equation of the parabola. The condition for the parabola is that d from P to D, the distance from P to D is equal to the distance from a point P to F. The distance from P to F, you have formula, distance formula. The distance from P to D is not that simple. So we cannot directly write down the equation of the parabola for the general case. So we only do the following thing. That's the first part. Analyze parabolas with vertex at the origin. So we will place this point at the origin, not the focus. The focus is not at the origin. This point at the origin. Also, we will place this axis of symmetry either along the x-axis direction or along the y-axis direction. Okay, so we will basically place either this horizontally or this vertically. Now let's see the first case. Okay, we see our first case. First case. We place the vertex at the origin, the x-axis as the axis of symmetry, and the focus we will write F as A0, the x coordinates A, y coordinates 0, and the directrix is vertical directrix is x equal to negative A. Why we can do that? Remember, the vertex is a midpoint. Vertex is a midpoint between the focus and the directrix. So to the right you have A unit, to the left you have also A unit. So to the left is negative A. Okay, so that's a reasonable setting. Okay, so that's our first setting. With this setting, we are going to study this P. P is here. P has coordinate x, y. Then the distance between P and F, we know it's x minus A square, y minus 0 square, and then square root. That's its distance. And the distance between P and this vertical line is a horizontal one. This point, it has x coordinate negative A. This point, it has x coordinate x, x-coordinate x. So for the horizontal line segment, the distance is d. The distance for the horizontal segment, the distance is right minus left. Right? They are horizontal, right minus left. If they are vertical, top minus bottom. Okay? So x minus minus plus x plus a is equal to x minus a squared plus y squared. That's a setting, but it's not as simple as possible. We want a simple form, not such formula. So we're going to square two sides. Square two sides, we get x plus a squared is equal to x minus a squared and plus y squared. Okay, and let's simplify. X plus a squared is x squared plus 2ax plus a squared. X minus a squared, x squared minus 2ax and plus a squared and plus y squared. Cancel. Cancel x squared from two sides, cancel a squared from two sides. And then we are going to move this negative 2ax to the left side. 4ax equal to y squared. Well, this one is much better than the first one. Okay, so this is our required formula. The formula is summarized by the theorem. Okay, so the equation of a parabola with vertex at 0, 0, focus at A0, and the directrix at x equal to negative a. A is positive, so be careful. A is always positive. In all the discussions of parabolas, this constant a is always positive. This y squared is equal to 4ax. That's the standard equation for the standard position. Okay, so the whole equation only depends on this constant a, and it's positive. Okay, so let's see the example. Whenever you see a, you can write down the equation. Find an equation of the parabola with vertex at 0, 0 and the focus at 3, 0. 3, 0. Okay, graph it. Vertex 0, 0, focus 3, 0. So we know a is a 3. A is a 3. The equation is y squared is equal to 12x. That's it. So it's so simple. Graph it. Well, 1, 2, 3. 1, 2, 3. It's negative 3. So the directrix is at x equal to negative 3. Focus is at 3, 0. The vertex is at origin, so the parabola looks like this. Okay, that's it. That is the equation and the graph. By hand, that's the best way we can do. Okay, so from the focus we can get the equation. Also from the equation we can get the corresponding focus, vertex, and the directrix. So we say analyze the equation squared equal to 8x. Y squared equal to 8x. And this is exactly our equation, y squared equal to 4a. So we get 4a is equal to 8, then a is 2. A is 2. Vertex is 0, 0. Focus is 2, 0. Directrix is x equal to -2. This is a vertical line. And this equation represents a vertical line. So it's not just a point, it's a vertical line. Be careful, it's a line. All right, that's it. That's an analysis. You know the vertex, you know the focus, and the directrix. Okay, and once you know this, we can sketch it. 2, 1, 2, 1, 2. Okay. Focus F. Okay. So we already do back and forth. From focus we get equation. From equation we get focus. And as we mentioned, this is one standard form. This is not unique standard form. We can place the focus on the right hand side, the directrix left hand side, or we can flip it. We place the focus on the left hand side, the directrix on the right hand side. If we do that, we will have another standard form. So let's summarize all 4 standard positions and the standard equations. First, the first case is our case we just discussed. If we have right focus, left directrix, okay, or if we have left focus and the right directrix, if this happens, you can't, you see here, you just switch them, you get a negative sign. Y squared is equal to -4ax, and again this place a is a positive. Why is negative? In this case here, you see this place x is always on the graph is always on the right hand side, so this x is always positive all the times. The graph is always positive. This place the graph is always negative. X-axis of the points on the graph is always negative, so you need a negative sign. If you don't believe me, you can go start from the definition and do the simplification. You will have exactly the same solution. Okay, so that's a left and right case, and we can also have top and bottom case. If we have the graph opening upward, and the directrix is below the x-axis, then this is x squared is equal to 4ay. You just switch x and y, right? You switch x and y, you get 4ay. X squared is 4ay. Open up, and symmetrically, you can also do it this way. F is 0 negative a. Directrix is y equal to a. Then this case is x squared equal to -4ay. -4ay. So we have 4 standard position with the standard equations. And let's see how do we memorize it. If you see the opening to the right or the left, you will have 4ax. To the right, positive 4x because x is positive. To the left, negative 4x because x is negative. If you have opening down, up, and down, if you have opening up and down, up is 4ay, down, negative 4ay because y is negative. Okay, so that's the way to memorize it. But still, you need to do practice to memorize. Okay, so now we already introduced all 4 cases. Let's just study them. Examples. Analyze the equation. X squared equal to negative 12y. Negative 12y. You see, when you see negative y, negative below, y along the y direction. It's like this. So here it's a negative 4ay. So negative 4a is negative 12. You solve for a, you get a is a 3. A is a 3, y is a 3. Here is a 3. This is negative 3. The focus is a 0, negative 3. So the vertex 0, 0. Focus 0, negative 3. Directrix y equal to 3. That's it. And if you want, you can write axis symmetry. Axis of symmetry is y-axis. That's everything. That's everything. 1, 2, 3, 4. Yeah, there are only 4 parts. Okay. Another example. Find the equation of the parabola with focus at 0, 4, directrix the line y equal to negative 4. Okay, well, let's see. 0, 4 is here. Y negative 4. So the graph will be more or less like this. And this, you see, it's a positive y. Positive y for a y. Negative x, negative for a x. Positive x, positive for a x. Negative y, negative for a y. Okay, so a is 4. So the equation is a 6. X squared is a 16y. Okay, x squared is 16y. That's it. It's a very simple if you know the focus and the direction and the vertex is the origin. In our standard setting, it's almost a one-step computation. Okay. Now let's see a less simple example. If we directly have the focus, then that's not the problem. Sometimes you don't directly have the focus. So it's like this. Find the equation of a parabola with vertex at origin 0, 0. If its axis of symmetry is x-axis and its graph contains the point -1/2 and 2. find its focus and directrix. And graph it. And graph it. Okay. Okay, whenever we have the vertex 0, 0, axis of symmetry, x-axis, two possibilities. Why don't you see these two conditions? Vertex 0, 0, symmetry x-axis. So either the opening is to the right or the opening to the left. Two cases. Which case? It depends on this point. This point, you see, the graph contains a point -1/2, 2. It means x coordinate can be negative. Here, the x is always positive. Here, x is always negative. So this is not the right form. This one is. Okay? This one, it opens, its opening is negative x. So it's a opening negative x. Let's see how do I read. Opening is negative x. It's negative 4ax. Okay, so let y squared equal to negative 4ax be the equation. Okay, so this comes from this fixed point. And also this fixed point satisfies the equation because the point is on the graph. Satisfy the equation. Well, let's plug in. Y is 2, so it's y 2 squared is 4. Negative 4a negative 1/2. Negative 4a times negative 1/2 is 2a. 4 is equal to 2a, a is equal to 2. Okay, so remember in the equation of the standard form of a parabola, a is a unique unknown letter. Once you determine this a, you determine everything. And for this one, a is 2, then from the graph you can see the directrix is x equal to, this is x equal to a. This is a focus is negative a is 0. So the directrix x equal to 2, focus is negative 2, 0. Vertex is 0, 0. That's you don't need to do that because they only ask you to compute the direct focus and directrix, and you sketch it. You just make it look better. One, 2, negative 1, negative 2. This is f. That's it. This is a graph. Okay, so again, we have 4 standard positions for the parabolas. 4 standard positions have 4 standard equations. They are very close to each other. Make sure you understand and distinguish them. And also, you should be able to determine the equation from some subtle conditions. For example, for this one, we know x can be negative. Only this x is negative, so we have to choose this. This x is positive. So you should be able to determine it from some subtle conditions. Okay? So the important constant is this a. A is determined, focus, directrix are both determined. And also remember, a is always positive. A is always positive. Okay? So this is a part of 1. The analysis with vertex at the origin 0, 0. And next time we will start to move this. Parabolas. We will see what's a slightly more general positions for the parabolas. Okay. Okay. We'll stop here for this video and do your exercise. Make sure you know how to do it by yourself, not just follow the video. The video, I believe I make it simple, clear, but you should be able to do your exercise by yourself. Okay? We'll stop this video and we will continue with another video. Okay.